In this video, we are going to see some examples of Laplace transform first shifting theorem. The first shifting theorem says when we have Laplace transform e power negative at g of t, we can convert this one into g of s plus a, and also when we have g of s plus a, we can convert this one back into e power negative a e power negative a t g of t pattern. Okay. Now here we have two questions. Now let's do this one by one, so it will be clear, right? Let's look at the first one. First one is we have Laplace e power 2t t cube. Now we are going to convert this one into s world. Okay. Now to convert this one, first we have to know what is our a value. From this one, if you compare this one with this one, we have to have e power negative at pattern, right? So this is negative negative 2. That's why it's positive. So a is equal to negative 2, and in our case g of t is equal to t cube, because if you compare this one, after e power something we have to have g of t function. In our case g of t function is equal to t cube. Okay, now Laplace transform says therefore g of s is equal to Laplace of g of t. So g of s is equal to Laplace of g of t. In our case g of t is equal to t cube. G of t is equal to t cube. Now we are going to find the Laplace transform of this function. Okay, to find this one we have to look at the table, and from this one you can see when we have t power n, we can transform this one into n factorial over Sn plus 1. Okay, in our case power is 3, so this is going to become 3 factorial over s power 3 plus 1, that's going to be 4. So s power 4, right? So this is our 3 factorial s power 4, and if you get the 3 factorial, that's going to be 6 over s power 4. Therefore this is our Laplace transform. Now what we are going to do is we are going to apply this a is equal to negative 2, then g of s plus a is going to become g of s plus a is going to become 6 over s. In our case a is equal to minus 2 power 4, and that's going to be the first shifting of this given function. Okay, that's how we do this. Now let's look at the second one. Second one is asking what is the Laplace inverse of 1 over s minus 1 cube. Okay, we have this one is already in g of s plus a, so let's note that one down. G of s plus a is equal to 1 over s minus 1 cube, and therefore our g of s value is going to be this value alone, 1 over s, and our a value is going to be this negative 1. Okay, a value is going to be negative 1. Now to transfer this one into t world, you can look at this equation. When we have 1 over s, here we have, okay, this is cube, we have cube right here, this is 1 over s cube, and here you can see when we have s power something, that is t power n. So in our case this is going to be Sn plus 1, so this should be, the t should be 1 power less, so the t should be t square, and since we don't have factorial on top, we have to divide by that factorial, so this is going to be n factorial, n is 2, so 2 factorial, we have to divide this one by that factorial, and this is what we got from table. This is let's note this one now, this is Laplace inverse of 1 over s cube. Okay, let's write this one somewhere here. Laplace inverse of 1 over s cube, that is this one. Okay, that is t square over 2 factorial. Now we have the inverse, and t square over 2 factorial, that's going to be just t square over 2, and this is one part, and we are trying to find this e power at negative at g of t pattern. This is our g of t function. Okay, this is our g of t function, and we found out a is equal to negative 1, so we can express our final answer. Final answer is going to be Laplace inverse of 1 over s minus 1 cube is going to be equivalent to e power negative at. In our case e power negative at is going to be just, let's close this bracket, e power negative at is going to be e power negative 1t, that's going to be just e power t, and then we have to plug this function, that is t square divided by 2, and this is going to be the final answer. I hope this helps. Thanks for watching, and this is the answer for the first one. Okay.